Hi, so today I'm going to explain how you can model and understand the rock cycle and how rocks are made using some simple materials you can find at home in the kitchen. So firstly we have some chocolate chips or chocolate chunks. We have dark chocolate chunks and light chocolate chunks. It's important to have this difference. Then we have some chocolates which are in the form of living things. So these could be chocolate shells, chocolate animals of some type. In this case, I've got some chocolate eggs. Then you'll need some cupcake holders. You need at least 3, but it'll be useful to have a few more as well, and I'll explain why shortly. You need a straw, a sharp knife, which you should take care with using, and you'll also need access to a microwave. Now this demonstration was inspired by a brilliant video on a channel called Rock Talk, which uses the same basic materials and the same basic idea, but I've added a few tweaks to make our rocks extra realistic. So using these materials and ingredients, we're going to make the main 3 types of rocks. So firstly, we have our sedimentary rocks. So here we see a rock that contains an ammonite fossil. That's a sedimentary rock. And then secondly, we have metamorphic rocks. So these are rocks that have been through an intense process of change. And thirdly, we have igneous rocks. So these are rocks that are formed from molten material cooling. And you can see with this particular rock, we have lots of these holes, which are actually air bubbles. And that's where our straw is going to come into the demonstration. So firstly, we're going to make our sedimentary rocks. So I've started off with a cupcake holder, chosen the green one for this, and I've got my chocolate chunks. So I'm going to pour in the chocolate chunks in layers, because when we have sediment on the surface of the earth, that forms in layers. So I'm going to pour in some dark chocolate first, sort of cover the bottom of the cupcake holder with dark chocolate there, and then some of the light chocolate chips on top of that. So we have a layer of dark and then a layer of light, and then we'll do the same again. A layer of dark. I'm also going to add some of my chocolate eggs. So here I'll take one of these and I'm just going to lay it down on top of one of the layers of our chocolate chunks. And then I'm going to add some more chocolate chunks, this time some light ones. And then at the very top, I'm going to add another egg. So here, as I've said, the chocolate chunks represent the sediment, things like sand grains that we see on the surface of the earth, and the eggs represent living things that have been buried by the sediment. And these, as we'll see, are what turn into our fossils. So to turn our loose grains into a rock and our eggs into fossils, we need the microwave. I've placed our ingredients in there and we're going to put the microwave on for 30 seconds. Now I'll take our ingredients out of the microwave and we'll see what we've got. So I can still see our chocolate chunks or our sediment grains in there. So on first inspection, it looks not too different to what it was originally. But if I take it out of the cupcake holder, and get the chocolate off my fingers, we can see that in fact, it's melted quite a lot. What's happened is that these loose grains are now joined together, so they're no longer separate grains of sediment apart from a few of them on the edges. Most of them are in fact combined, so we've turned our loose sediment into something that resembles a rock. And we can still see our egg here, there's the white egg. So this shows how when living things get buried in sediment and that sediment turns to rock, that they can still be preserved as fossils, much like our ammonite. So that is our sedimentary rock. Next, we're going to make a metamorphic rock, and we're going to use, in this case, the purple cupcake holder. So we do exactly the same as what I did previously. So we have the same starting sediment in the same layers. So we add the dark and light chocolate chunks, along with a couple of our eggs, so our living things. And I'm going to take this to the microwave again But this time, I'm going to set the microwave for 1 minute. So I'm quite intrigued to see what we've got here. And we immediately see that that looks quite different to what we had before. It almost looks like a chocolate pudding. So something else that happens when rocks become metamorphic is that as well as these being heated, they're also pressurized deep within the earth. So here we can use our extra cupcake holder just to squash that down a bit. So I'm just going to press down, and it's becoming a bit of a sticky mess, but that's okay. That's what we expected. So this is the end result. And what you'll notice is that there's a lot of melting here compared to when we just put it on for 30 seconds, but we can still see grains. So we can still see these chunks of chocolate in there. Something else you might notice is that we can hardly see any trace of our egg anymore. So we don't have a fossil in this rock. Well, we had 2 eggs in there, and there's one white one towards the top. I think there might be just a hint of it around here, but yeah, very unclear. And that's why many metamorphic rocks don't contain fossils, because they may have been there in the first place, but they don't survive this process of all the grains, the chunks within the rocks being changed so much by heat and pressure. And what we're looking at here is very much as this rock might look when it's deep within the earth. So it's still quite squeezable. It hasn't solidified to become anything like a rock that we see at the surface yet. So what we're going to need to do is cool this. So I'm just going to let it stand and cool to become something more like the rocks that we see around us. But what you could do if you wanted to speed this process up, and what the video on the Rock Talk channel suggests, is using an ice bath so you can cool this quickly and make it into its finished product. But in the meantime, while we're waiting for our chocolate to cool, I'm going to make an igneous rock using the red cupcake holder. So we do exactly the same. We add our layers of dark chocolate chunks and light chocolate chunks. We even add a couple of fossils. And this time we're going to put our funny cupcake in the microwave for even longer, because if you remember, igneous rocks are formed from molten material. So because we want to melt all this chocolate, we're going to put the microwave on for 2 minutes. Well, this is pretty exciting. I had to actually stop the microwave early. I had to stop it with 20 seconds still to go because our chocolate rock was starting to smoke. And as you can see, it's bubbling and it's smoking still. So I'm going to remove this very carefully from the microwave. I've let it cool down a bit. It's still quite hot though, so just be careful with this step. So you can see that our chunks have pretty much completely melted. There's a few of them at the edges here that haven't quite, which is something that can happen in igneous rock. We can still have some grains that don't quite completely melt, but if I give it a little stir with this straw, we can see that it is essentially a melted mass. All liquid chocolate, melted chocolate in there. Now we don't need to pressurize this rock. Some igneous rocks do get very deeply buried in the earth and do get pressurized, but some, often the kind that come out of volcanoes, don't. What we can do though is put some air bubbles in this rock, like we see in this igneous rock I showed you at the beginning with all the holes inside it. So this is where we can use our straw and just, again, making sure it's not too hot at this stage. Just blow into that until we can see some bubbles forming. And that would be very like a lava that we see coming out of a volcano at the surface of the earth. There's also obviously no sign of our fossil in this igneous rock. That has completely melted. So there we have our sedimentary rock with lots of grains still visible, joined by melted chocolate. And then we have our metamorphic rock where we can still see grains, but there's a lot of change that's taken place and those grains look quite different. And then we have our igneous rock, which is completely different to what we started with. I think we could have done with just putting this on for 1.5 minutes, probably 1 minute 30 seconds, rather than 2 minutes, because in my microwave anyway, that was getting a bit smoky towards the end. So our final step is to let these rocks cool. As I said before, you could do this using an ice bath, like with the video I mentioned, or in this case, I'm going to put them in the fridge. So it's now 1 hour later, and I'm going to have a look in the fridge at how our rocks are doing. Well, we can see that these are now chilled and are very much solid. So we're going to take these apart and have a look at what the inside of the rocks look like. So starting with the sedimentary rock, we can see this fossil here, and we can see the grains, our chunks of chocolate here, all joined together, still very much like they used to look before we had our heating in the microwave. And if I cut off a little piece here, we can see inside the rock, basically, it's a big set of grains that are very similar to how they were when they started, but now joined together. Then let's have a look at our metamorphic rock. So I'm going to try and take this out of the wrapper, and we see a number of grains are still visible. We can see stripes, actually, stripes of the darker and lighter layers where we've got grains which have merged into each other. This is very like we see in real metamorphic rocks. And if we slice this sample open, we see the same. Still hints of those grains, but they're largely fused with each other and don't have the same shape as they used to. Now onto our igneous rock to finish with. So we see a very different melted, bubbly texture with just hints of the grains at the very edges. For the most part, these chunks of chocolate have completely melted, and we'll see if we cut that open, it's just a mass of chocolate. If we look closely, we can see the bubbles, and these bubbles look very like the holes that we see in our real igneous rock that actually makes this rock quite light. So I hope it's been useful to see how we can make the different kinds of rocks, sedimentary, metamorphic and igneous, using chocolate. And the next job, of course, is to eat what we've made.